Okay, moving back 10 years. We can see, all right, there the population is starting to go up. You can see a change. You can see the up and down in the CO2 concentration over the year, and you can see it kind of edge up over that 400 mark. Global temperature goes on pretty steady, goes up a little bit at the end. And sea level also has been dead steady, and then there's a little tick up at the very end. Now you can see the same dots in the perspective of 100 years. Whoa, look at the population has gone up from almost 2 billion to almost 8 billion. That's like 4 times. That's outrageous. And you can see the CO2 go up about 100 parts per million. That's a lot. So you can really see the change and see the swing. Sea level's been...
That CO2 rise, by the way, it's risen by 1/3.
Yeah, which is a lot.
Okay, it's risen by 1/3. 35%, somewhere in there. Go back to sea level rise again.
I'm going the wrong way. 10 years ago. Okay,
all right, so when we were saying you couldn't, not much was happening, you start to see it here. That's 22 centimeters for those who think in the Old English system there, that's 8 inches. 8 inches of sea level rise is what's causing now the Keys to be flooded for a month at a time and flooding along our coasts. And we've got parts of, Norfolk, Virginia, Hampton Roads, those guys are really in serious trouble. The U.S. Navy's been pouring money in there, which is the only reason they're still functional. Miami Beach has spent $500 million and they're just scratching the surface. 8 inches is significant.
Right, but you ain't seen nothing yet. So here we are at 100 years ago. We're going to zoom back again. Ready? Zoop. 1,000 years ago. Now we start to see the real rise. Now we start beginning to understand that this population CO2 is not a simple blip in the system, that this is a real change from what had been a steady state. So 1,000 years ago, we're going to zoom back again. Zoop. Boom, 10,000 years ago. Now, this is a little bit the oh shit graph. This is the one where you really see that over 1,000 years that the CO2 has been pretty steady, and then bang, we go up quite a lot. Likewise, I mean, population is just unbelievable. This is at that scale. And sea level, here you see the dip in sea level, which was the beginning of which was the end of the ice age.
It's actually not a dip. Can you go back one?
Mm-hmm.
Yeah, so it's not a dip in sea level. It's a
rise in sea level from the previous condition.
But here's what's really interesting. Look at this here. So if we just go back 7,000 years, 6,000, 7,000 years, which is about the history of our civilization, recorded history of civilization, maybe is it's 5,000 years. The sea level's been flat. The sea level has stayed still for all of recorded history.
Yes, all of civilization.
So mankind, we believe that the sea level doesn't change because that's everything we've known as a civilization. But this graph, you move to the left and you see the sea level drops precipitously at the end. So before we were recording history, there was stuff happening.
Yep. So here we've got all of civilization. We've got Egypt, we got Stonehenge, we got the classical age of Greece. All of civilization is in this kind of snapshot. So here we are, 10,000 years ago. We're going to go back again. Here we see the entire ice age. We see the dip in CO2 from here where we are about, and we go down to about 100 points in CO2 level. We see the temperature go down to a low of 8 degrees Celsius. That's really cold, by the way, really, really cold.
That's the average temperature across the surface of the planet.
Across the planet. The tropics stayed a lot more steady than the poles did. So the further north you went, the more dramatic the change was. And look at the sea level. I had to shift scales here, that we were at the scale of meters. Now we're at the scale of hundreds of meters, down 120 to 130 meters. Whoa, that means that all of the continental shelf was exposed as land. All right, so here we are. We're going to go back again. Whoops. There we go. Now we see ice ages come and go. You know, ice age was a big deal for us, but it was only one out of a lot of them. And so we see the CO2 level go up and down, up and down, up and down, temperature, boing, you know, up and down, up and down. I mean, I've become really interested in the Eemian period, which was the last interglacial.
So if we can look at this for a second, it looks like the ice age itself lasts a pretty long time.
Yes.
And then there's
the interglacial is short.
A brief warm period, and then boom, you're back to a long period of ice again, and a brief interglacial. Actually, this is a complicated one.
Yeah.
But then the same pattern. It's cold for quite a long time. You know, you take a brief tropical vacation, and bang, it's cold again.
Yep. And what you need to see here also in terms of sea level rise, that when the sea level is going down, it takes a lot longer than when it's going up.
It's like the reverse. So,
yes.
so the sea level is high for a long period, and then it's low for a short period. And that's because it's taken so long.
Taken a long time to get down there.
But if you go up to the black one, I think you find out the reason why.
Yeah,
that's carbon dioxide.
Carbon dioxide, and they go down slowly, and then boink, goes up really fast, and down slowly, and boink. And what our friend Hal Wanless said is that the oceans, you know, they make a beach where they meet the land. And when the sea level is going up, the oceans just leave that beach behind and head inland. And they don't establish another beach until they're ready.
Until they're stable.
Yeah, until they're stable. Okay, here we go back again. 1 million years. Here. Boing. This is 10 million years ago. And here was we can see the last time that CO2 concentration was where it is now. About 3, 4, 5,000 years ago.
1,000?
I mean, million years ago, I'm sorry, powers of 10. About 3, 4, 5 million years ago was the last time that CO2 concentration. Okay, where were we? So the temperature was 2, 3, 4 degrees warmer. We're trying to hold our temperature change now to 2 degrees. But here we are up at 415. Oof. Sea level.
So hang on, so this gets back to Darren's point. So he said we're about as warm as we ever were right now. In the whole ice age cycle. So you're saying
seems like we're really close. Seems like we're not that far from that high point.
Exactly.
So you go back to that level of CO2, and you are warmer than we were at the peak of the last ice age cycle, which was the pretty extreme cycle.
Right. And sea level was 10 to 20 meters higher. We were up in North Florida a couple of weeks ago, and that would be the coastline essentially. So if we go back from here, boom, there we are, 100 million years ago. CO2 is just out of here. It is off the chart. Up, you know, they have recordings of up like 1,500 parts per million. Temperature, oh my heavens, 27 degrees. You can't imagine how hot that is. That is just an oven.
That's 80 degrees Fahrenheit.
Yeah, I mean, that's
the average for the planet.
Right, average for the planet. I mean, 100 degrees centigrade will boil water, but so this
will melt asphalt.
Yeah, right. Okay, the sea level was up 120, 140 meters. That covers like the Midwest. You know, it's a very different world to 1 billion years ago. And here you see the extinctions that in this zone over here, this is when the Earth was just a snowball. There wasn't anything living here really at all. The Cambrian explosion, that's when plants were invented, algae in particular. Here you've got extinction, 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 extinction. Here's the most recent KT extinction, and they say that now we are moving through the 6th great extinction.